All right, so here we go. DMS, that stands for degrees, minutes, seconds. Now on a calculator, you can change this to a decimal really easy if you know where these things are. That and that are located under the angle menu. Okay, and this one is located right above the plus key. You got to use your the alpha button to get that in there. Then once you put all those in there, you just hit equals, and it tells you the decimal for it. Would you please do that right now? You already done? What'd you get? 8.5 what? 0.5. Okay, just make sure you know how to do that. That's fairly simple. Now, what if I have 8.5, which is close to 8.505? What if I have 8.5 degrees and I want to change it to DMS? You just type in 8.5, and then you got to go change to DMS. It's under the same menu, the angle menu, and there's a little arrow DMS button. I'm guessing it's 8 minutes and, or it's 8 degrees and 30 minutes. Okay. All right. For the fact that we've got so much to cover here, I don't want to spend a lot of time on simple stuff. I guess I'll show you real quick. So it's 8.5, and then change to DMS, second angle. DMS is right there. Enter. Enter again. And good. Okay. Make sure you know how to do that. Moving on. Changing from degrees to radians. Use the right fraction here and figure that out. 30 degrees would be what? Radians. Well, you're either going to multiply by 180 over pi or by pi over 180. And you got to think in terms of canceling. All right. So, did you multiply by the pi over 180? I hope you did, because that will cause you to have the degrees cancel, and then your answer will just be radians. Remember, radians don't have units. 30 pi over 180 can be reduced. I'm going to go 30 goes in here once, 30 goes in here 6 times 3 is 18. Yeah, so 1/6 pi or pi over 6. Do you get what I said there? Now, could you use the decimal for that? Sure. Take pi, divide it by 6, you get a decimal. Okay, but the point is that you are able to leave these sometimes like this. You're going to have that on today's worksheet. You have a little worksheet to do that has some practice on that. All right. It depends what they ask for. If they ask for a decimal, give them a decimal. If they don't, then you can just give them that. It's faster. Don't have to put it in the calculator even. All right. Moving on. SOHCAHTOA. Sine is, what are these? Over. And cosine is over. Hypotenuse, and what's this one? Tangent is opposite over adjacent. Okay, good. And if I had it set up like this for this triangle, and I told you that this was 7, would you please figure out what that is? Use your calculator quick. Because I've told you the opposite, and I've told the adjacent. And you can use this calculator to get this, and then you got a little equation. Just solve it. Remember, on your calculator, make sure you're in degree mode. Otherwise, you'd be using 30 radians, which would give you a totally different answer. All right, was tangent of 30.5? Do I remember that right? Is it? 0.57, okay. All right, equals, what's the opposite from the 30? Well, we don't know. So what do I put? X. Over, what's the adjacent side? 7. Now you just got to solve that. So, get the x alone, multiply by 7 on both sides. 7 times that's about 3.6, 3.7, something like that. Okay, I'm way off. 4 point what? 4.04. Why is that? Oh, it's more like about 0.6. And 0.6 times 7 would be like 42, and that's why it's a 4. Okay, good. Anyway, that's just your basic trig. Do you remember these? This is x, and this is x, and what's that? Not 2x. X times the square root of 2. Okay? And how about on the 30, 60, 90? Well, if this one's x, what's this one? 2x. And what's this one? X square root's of 3. Okay, good. Moving on. Sectors. That little thing is a sector, and you learned this yesterday. A SOR. The S is this little, it's not really the sector, because the sector is this whole thing, but it's the arc. This little thing is how many degrees the central angle is. It's that. It's called theta. And then r is the radius. So if I tell you that this is 10, you should be able to tell me, 10 inches, how long that funky looking red line is right there. Figure it out. Oh, wait. You need to know something first, don't you? What do you need to know? How many degrees that angle is. Does it look like, if I made this as like a 90, does it look like it's about a 45? Yeah, it's about a 45. So let's say it's 45 degrees, but remember that would not work because you'd go 45 degrees times 10 would give you 45 degree inches. Why don't I do that? Because you change this into what? Radians. So you do not put in the 45 here, you put in, well, you could put in 45 degrees times that little factor, which changes it out of degrees, which would be pi over 180. Or you could just do that on the calculator and get the answer as a decimal. And then I times it by 10. And that's in inches. Notice the degrees will cancel, and radians don't have any units technically. I touched that yesterday. So when I do 10 inches times something with no units, my answer's in inches. S equals, somebody that's multiplied that all out, 7.8. Raise your hand if you have about 7.8. Good, lots of you. Must be right. Now if you just look at it, doesn't it look like that red line should be shorter than the radius? Yeah, so that makes sense. 7.8 seems reasonable. It's a little less than 10. All right, moving on. These are called concentric circles. You will see them again. Concentric means there's one inside the other, and that their center is in exactly the same spot. Okay? So if we, you can do all kinds of funky problems with this. Say this is 8 and this is 2, then the total's obviously 10. And then they could ask you about the difference between these two lengths of sides, for instance. Well, you could find them if you knew the angle. Let's say this is 40 degrees. You could see how long is this one and how long is that one. Well, they have different radiuses. The one has a radius of 8, and you could figure out this one. And then use a radius of 10 to figure out that one. Anyway, so sometimes they do that. Next, just a quick reminder on this. 0 degrees is straight north. So if I said you were in the middle of Lake Mille Lacs, and I said, set a course for 270 degrees, and it'll bring you right in here. Yes? Which way are you heading? You're pointing, just say it. Said 270? It's actually directly west, I think. Isn't that where 270 is? I think that's where 270 is. Because 90's here, and 180's here, and then you add another 90. See what I'm doing here? 9 times 2, 9 times 3. Okay, so anyway, yeah, 270, so it'd be pretty much heading straight west. All right, so you only need one number for them to tell you which way to go. So if you were flying a plane, they could say plot a heading for 10 degrees to get here. And from wherever you were, you tell the computer to go 10 degrees, and that's basically would be like that, and it must be that you just need to head north-northeast to get to where they are. All right, moving on. A nautical mile, this is really cool, but it's not something that we need to do today, and we have very little time. So a nautical mile is different than a regular mile because a nautical mile is curved, because it's based on the curvature of the Earth. Okay, see how there's a big arc there? The Earth, in case nobody's told you this, the surface of the Earth is curved. And that's based on lots of really smart people telling us that. In the old days, it used to be the world was flat, and everybody really believed that. But they never really figured out why you couldn't see, like if you're out in the ocean, you couldn't see the shore. Well, do you know now? It's because of the curvature of the Earth. That's why you can't see the shore when you go far enough out in the ocean, because the Earth is curving, and eventually the stuff that's on shore gets to be short enough that you can't see it anymore. Okay, so if you're actually, did you know that if you get out to the middle of Lake Mille Lacs, that you can get to a spot where you can't see land in any direction? Just in the middle of a lake. And so based on the curvature of the Earth, we can figure out how far that is. But anyway, if there had been big buildings on shore, you'd probably be able to see those, maybe. Because of the curvature of the Earth, you just can't quite see the shoreline. Okay, moving along. This is talking about this white boat here went at a heading of 42 degrees, 30 minutes. And this red boat went at a heading of 52 degrees, 12. Do you see how they're going to different places? Because the one's on a different heading than the other. And eventually they're a distance apart from each other, right? Which, if you wanted to think of it as a curve, it's sort of like a circle. Sort of like they're on a great big circle here. Okay, and the distance apart from them can be measured, and if you're counting in curvature of the Earth and stuff, you can do problems like this. Not going to do that one with you either. Don't have time. All right, let's talk about this. You need to be able to convert things like dollars per hour into pennies per second. Write this one down. 225. Put dollars over 1 hour. Does anybody make $225 an hour? Yep. My lawyer does. I think it was about that anyway. So it's very painful when you have to talk to the guy for 15 minutes and then they actually write you out a bill for 15 minutes or 1/4 of $225 just to talk to him for 15 minutes. All right, so if I want to change that to pennies per second, do you get that I have to multiply it by something? This is all about getting things to cancel. And I want my dollars to cancel, so I'm going to put $1 down here. Do you know what $1 is in terms of pennies? $1, 100 pennies. Now, do you get that now my answer will be in pennies per hour? That's not what I want, is it? So I got to put something here that'll make the hours cancel. So the hours need to go on top. That way they'll cancel. And what's a fact I know about hours and seconds? Just used it yesterday. 1 hour is 3,600 seconds. And now hours cancel hours, and now my answer is in pennies per second, and I just have to divide the top divided by the bottom. Do you get how to do that kind of a problem? I heard you doing something like that in science too. Is that accurate? Okay, so moving on. This guy, Andy Green, set the world record for speed. There is his car. Isn't that kind of cool looking? And it was 763 miles per hour. They do it out in the desert where it's incredibly flat, and they can just go insane speeds. So let's figure out how many feet per second he's going. The other day we figured out in a car traveling at highway speeds you're going about 100 feet per second. Let's see how fast this is. Always start by writing it that way, and then figure out what you want to cancel, and then put in the right numbers, multiply them out. 5,280 feet in 1 mile. So I'm going to put the mile on the bottom. Know why? So it cancels. And 1 mile, 5,280. Now I got feet per hour. That's not what I want. Feet per second. So in 1 second, in that long, how fast are you going to be going? Or how far are you going to be going? Sorry. So then we need our 1 hour to cancel. And hours cancels up there. 1 hour is 3,600 seconds. So multiply those all out. I actually want you to see this number on your calculator. How many feet are you going in 1 second when you're setting the world speed record? Keeping in mind that a football field is 300 feet. So how many is it? All right. So that's more than 3 football fields in that long of a time. Isn't that insane? Oh, it'd be really cool to be going that fast. Really scary too. Yeah, there's very powerful G-forces, but basically when you're think about it this way. That's the acceleration part though, right? Because like when you're sitting in a plane that's going 600 miles an hour, are you like plastered back in your seat? No, because you already got up to that speed. It's the getting from the 0 miles per hour up to the 600 miles an hour. There was a little time in there where you actually feel it, and that's when they're taking off. You kind of get pulled back in your seat a little bit. Well, when they're accelerating, they have a lot of G-forces on them, but when they're actually up to top speed, no more G-forces than you in your car. Yes? Speed of sound is, I know that they are breaking the sound barrier, so I don't know what the speed of sound is, but I don't know. I just don't know. No, the fastest planes go, every Mach 1 is the speed of sound. Mach 1 we passed a long time ago. They're up to like Mach 6, which is like 6 times the speed of sound. So the fastest planes go way faster than the speed of sound. Okay, anyway, moving on. The saw question. All right. I actually have a saw that I want to bring in and show you this sometime, but this is called angular motion. And we need to try to figure out how fast are these little blades really moving when you change it into like total feet that they move. In other words, if this saw blade is going around and around and around, isn't that cool? If this saw blade is going around and around, do you get that one of these each, if I just pick one of these little teeth here, I can put a little mark there, I don't know if that'll move with it. I suppose I could group it with it. Anyway, that little mark, if it were moving, would be going how far? Well, when it goes around once, it's going one circumference, right? So we need to know the circumference of this thing. And that's where you needed to know those formulas about a circle. You remember the formula of circumference? All right, so let's just figure out one little thing at a time on this. I'll tell you the general idea. It's if we know that the saw is going at 7,200 RPM. You know what RPM stands for? Rotations per minute. Okay. If the saw is going at 7,200 RPM, 7,200 rotations per 1 minute. See how it's just like that other problem? If the saw is going 7,200 rotations per minute, you can figure out how far is it going, how far is one of those little teeth going, and you could think of it this way. If you had a saw and you started it, they actually have this. This is insanely dangerous. They have saw races where they'll get a saw started and they'll let it go and it digs into the piece of wood. It just like starts to fly across, you know, it goes a long ways really fast. Okay, because this is like a wheel, sort of like a wheel on a car, right? If you had a little matchbox car that was, or like a little remote control car, and the little wheel spins around, it can like pull something. Well, a saw, when it's, if you let go of a saw when it's like cutting wood, it can just fly. I mean, they can go insanely fast. Okay, so anyway, how fast can they go? Well, if it's 7,200 rotations per minute, what do you need to know to be able to answer the question? The diameter, good, or the radius, all right. And this saw blade, we are going to say, has a radius of 2 inches. I'd like for you to figure out for me, do your best, how far does that little, no, not how far, how fast is that going in miles per hour? You know what? It'll be way harder than if I ask you for inches per second. I'll ask for that. Change rotations per minute into inches per second. So you should be thinking to yourself, well, I'm going to multiply by something here, probably even by a couple things. You got to be thinking about making stuff cancel. You want to get it into inches per second, yes. All right, so here's one of my little things. I got to do minutes here because why? Because I want it to cancel. What's a fact I know about minutes that's going to help me in this? 1 minute, there are 60 seconds. And I should label that SEC. 1 minute, 60 seconds. All right, next thing. Now my minutes are canceled. Now I got rotations per second. How do we get rotations into inches? Well, I got to get rotations to cancel, right? So I put a rotation down there. One rotation would be how many inches? 12 point, what'd you get? 12.56? 12.57, fine. And that is inches, because that's the circumference of this thing. I bet you did that with C equals pi d, and then stuck in the diameter, which was 4, and 4 times pi is about 12, so that makes sense. All right, so final answer, after I cancel my rotations and my rotations, is I got inches per second. How many inches would this thing go in 1 second? How many? Would you read me the numbers clearly? 15. What's the next digit? Thank you, good enough. Is that right? 1507? Oh, I don't care about does it go farther? Or are we talking about rounding here? Okay, thank you. If you guys just speak up nice and loud, I can hear you and I'll write it down. Okay, so it's 1507 or 1508, and that's inches per second. All right, so the other kind of problem that you need to know about, since I seem to have, I don't know how much time I have, let me double check here. Oh, I got lots of time. I got till 12:01. All right, so this is actually a book problem. And so since it's, let me see if it's in your assignment here. I haven't written your assignment down yet. I think it is in your assignment. So number 67, would you please get to a blank page so that you can use this for your actual homework problem? What's your what? I haven't written it down yet. So hold on. Okay, so number 67. Out of the book, it's off of page 366. Assume that the two cities have the same longitude. That is, assume that one is directly north of the other. Do you get that San Diego and LA are pretty much right, and one's north of the other one? Because they're both in California. It's a long, skinny state that goes up and down, and so it makes sense that they would probably be directly north of each other. All right. Find the distance between them in nautical miles. You remember how nautical miles are actually curved? So what you have to imagine for a second is that here is LA, and here is San Diego, and that the one's directly north of the other, but that we're going to be talking about this in terms of going all the way to the center of the Earth. So, like, if this is the center of the Earth, and we could draw lines like drill a hole from LA to the center of the Earth and from San Diego to the center of the Earth, do you get how the distance between them would actually be curved a little bit because of the curvature of the Earth? Okay, I wish I had a 3D model I could show you, but basically, if you get to LA and San Diego, do you get that they're far enough apart from each other that you couldn't see them even if there was no trees or anything in between you because of the curvature of the Earth? Okay, because you could not see them. So the curvature of the Earth, we're going to factor that in. That's called nautical miles there. All right, so do you see how this is basically, if this is, I'm now going to go around the whole rest of the Earth here. Okay, and now my radius is way off. I'm going to just fix that quick. Okay. Do you get that this is basically a giant circle? And it's basically just an arc length problem again? So all of a sudden I can use that little formula yet. S equals theta r, SOR. And S is the distance between LA and San Diego. That distance right there. And I got to find that by using theta, which is the degrees. Oh, and it tells me that. 32 degrees 43 compared to 34.03. That means the difference right in here between the two. See, if this one's at 32, again, San Diego's at 32 degrees 43 minutes, and this one's at 34 degrees 03 minutes, then the difference between the two, I just have to subtract the two, turn that into a decimal, and then I'll know that this is like 2 degrees or something, 2.1 degrees. We have to figure this out to figure this number out. Then it tells me use that for the diameter of the Earth. So that means the radius of the Earth would be half of that. Yep. So we take 7,912 divided by 2. And now I'll have my degrees I'll put here. I'll have my radius that I'll put here, and I'll be able to solve for it. Okay, we're going to divide this up and do it in manageable chunks. Would you please figure out what the 7912 divided by 2 is? Would you please convert, in fact, your whole row, convert 34 degrees 3 minutes into a decimal. It'll be 34 point something. Would your whole row please convert 32 degrees 43 into a decimal, 32 point something. Okay, tell me when I got the numbers. You got what this is? 3956. Thank you. And do you guys have this 3403 converted? 34.05. Do you guys have the other one converted? You guys get the same thing? Okay, good. So then, next, last row against the wall. Subtract these two and just tell me what the difference is. That'll tell me how many degrees this is exactly. And everybody, on your paper, make a little picture of this circle, because this is your problem number 67. And I'm not just going to say, I did it on the board so you don't have to do it. I'm doing it to help you. Okay, so make your little circle. And now, how many degrees is that, people against the wall? One more time. Thank you. 1.34 degrees. And now that's degrees, though. Are we supposed to use degrees in this formula? No. Now this row, would you guys calculate how many radians that is? 1.34 degrees is going to be a really small number of radians. Can anybody verify that in that row? Okay, thank you. 0.023 radians. So I'm going to actually get rid of my 134. If you wrote it in there, you can just say equals 0.023. That's in radians. All right, now we can actually do the formula. 0.023 times 3956. Because I'm just doing 0.023 for that. And my radius was 3956. And now we're going to get a distance in nautical miles, because nautical miles are curved between these two cities. What'd you get? 95.52. All right. Anybody verify the 95.5? Yes? No? This times this? Uh-oh. 90 point what? 90.9. Okay, close enough, 90.9? All right, so, it's all right. I make mistakes too. So about 90 miles between these two cities. That's in nautical miles. Nautical miles are curved. Now there is actually an exact calculation for how big is a nautical mile compared to a regular mile. It's right here. A statute mile is 0.87 of a nautical mile. So LA, if anybody asked how far away is LA from San Diego, it's not really 90 miles. Okay, and just another thing, we've done some rounding here, so it's going to be off a smidgen. But it's 90 nautical miles. So to figure out how many land miles that is, you'd have to use a factor. Yes. For sailing, when they're talking about knots, that's nautical miles per hour, as opposed to regular miles per hour. And they are a little different. So if I'm going 30 knots, I'm definitely not going 30 miles per hour. I'm going 30 nautical miles per hour. Do you get why you would measure in knots? Because if you're out in the ocean, it's a giant curved surface. So you actually, it makes some sense why they do that. And a nautical mile is defined as this little angle right in there is 1 minute. And this arc right here that would be on the Earth's surface would be exactly a nautical mile. 1 nautical mile. Yes? If you're on land and you're trying to measure, so yes, sometimes they measure distances on the ocean in regular miles. It's just, bottom line is that one's longer than the other. Okay? And, you know, you can measure both, you know, like on land. Really, if you're driving a car, aren't you on the surface of the earth and it's curved, and you know what I mean? So you could be using nautical miles there too, but you usually don't. So it's just different lengths. If you actually had to run a regular mile, like the 1 mile run in gym, okay, that would be different than a nautical mile because they're just different lengths. All right, 30 minutes. I hope you learned something. And the homework will be posted. I guess I'm just going to pause a second and see if I can. Okay, so your assignment is there, page 357, the ones that are highlighted, and there also is a little worksheet, 4.1. In my kids' classes, I am telling them they have to have the worksheet done by tomorrow. The book problems, they're going to probably have an extra day to get done.